Ladies and gentlemen, welcome. I'm Jacopo Lazzari, and I will be your host to today's Research in 5 Minutes, the Data Mentalist. First of all, let's say we asked some of you to choose an image and look at it. Would we be able to know what you are watching given that we haven't got any paranormal power? This is exactly our aim. Starting from an EEG, we want to extract features that would allow us to predict what you are watching, and, as a consequence, achieve a deeper understanding of cognitive processes, which is fundamental when dealing with conditions such as ADHD. But first, some more insights on the problem we are facing. The image categorization problem has been faced through the use of event-related potentials, in particular through the extraction of discrete statistical quantities that would later undergo an ANOVA test to investigate if the features coming from different groups are statistically different. The dataset we've been working on contains 50 EEG responses to a presentation of images from the Things database. Of these images, we consider 5 categories: tool, animal, vehicle, body part, and food. Regarding the EEGs, we study the average between the occipital channels. Every great magic trick consists of 3 parts or acts. The first part is called the pledge. The magician shows you something ordinary. The second act is called the turn. The magician takes the ordinary something and makes it do something extraordinary. But you won't clap yet, because making something disappear isn't enough. You have to bring it back. That's why every magic trick has a third act, the hardest part, the part we call the prestige. Now, about the pipeline. After our first part, which is necessary to clean the signal from artifacts and noise, and in which we obtain the event-related potentials for each category and for each patient, our method is divided into 2 branches. One represents the functional approach, our way to reach the final goal of classification. The other one represents a more traditional approach, which will be later compared to the functional one through a linear correlation analysis and through the analysis of classification scores. The traditional branch is the one that can be viewed as the pledge of our statistical magic trick. This centered around the extraction of discrete features from ERP's components. In our case, we choose to study the P1, N1, N2, and P3 components, since it has been proven that they play a relevant role in the image classification problem. From them, we decide to extract the signed area and the 50% peak latency. On the other hand, the turn is represented by the functional approach. This part relies completely on functional data analysis, a branch of statistics that focuses on studying continuous curves rather than discrete measures. The advantages of this kind of approach are numerous. For example, it lets us evaluate ERP differences from a morphological point of view. Then, it allows us to extract functional features that will, in turn, enable us to take into account the shape of the component in its entirety. As the first step of our functional analysis, we smooth the RPs through a basis function representation to obtain functional objects. Then, for each category, we remove the outlying signals thanks to a functional box plot. Now, we implement a functional principal component analysis. Thanks to it, we're able to extract 4 functions that cumulatively explain 85% of the total variance of the data. As you can see from the slide, the scores associated to each principal component function vary in a significant way between the groups. About the final part of the pipeline, the comparison, to compare the 2 approaches, we use 2 methods, a linear correlation analysis and a support vector machine classifier, the former to study the correlation between discrete and functional measures, and the latter to see how they influence the classification. And now, it's time to bring everything back for the prestige. As you can see, the majority of functional and discrete measures are heavily correlated between them. This, in addition to the fact that the classifier performs far better when fitted to the functional features rather than the discrete measures, brings us to our conclusions. The first conclusion is that principal component functions capture morphological aspects related to ERP categorization better than discrete measures. As a consequence, functional data analysis emerges as a whole as a valid approach to solve the image classification problem. So, in conclusion, everybody can be a mentalist. All they need is an EEG and a statistics book. Well, that's all. Thank you so much for your attention and have a good day.